Now that you've made a couple of experiments in a few different ways, and you've used some of those common Python machine learning libraries, now it's important to talk about what to do to help start to add some of this MLOps workflow to your model experimentation. So to do that, we're going to spend a little bit of time talking about Git. A lot of machine learning engineers tend to run experiments in notebooks, and they don't really have to do a whole lot of just code repository management. So a quick little intro to Git is just that this is the tool we use to track code changes between experiments. So if you change a hyperparameter, if you decide to try out a different algorithm, anything that you change programmatically is going to be versioned with Git. So I have seen some teams use subversions or SVNs like Tortoise SVN, but Git is a much more up-to-date version of that. So go ahead and check out some of the docs on Git, but the main thing to know is that this is one of the tools you can use to track those code changes. And this is a version control system that is wildly popular. It's used for pretty much all kinds of development, front end, back end. It doesn't matter what language, infrastructure, machine learning projects use Git a lot. So this is a very widely supported tool, and you'll see it probably used even within your company if it's not being used by the ML team yet. This is something that makes team collaboration so much easier because as you run experiments, again, you'll be changing little things here and there, and you need to know what was the difference between the code in this experiment versus the code in another experiment. And then sometimes you'll want to compare those code changes between teammates. So there might be some kind of central repository that you have. Maybe it's in GitHub, and you just have this repo where everybody pushes all of their experiments. So that's one of the ways you can start to use MLOps to make your team interactions a lot smoother. Something else that Git offers, usually in conjunction with something like GitHub or GitLab, is that you can automate parts of your MLOps pipeline. So maybe there's some type of formatting or code linting that you want to enforce on every experiment. You can do that with Git and GitHub. So you might create something called a GitHub action that runs every time a pull request is merged to a specific branch. So this is one of the ways that you can help keep your code consistent across team members, across experiments, and you don't start to get into this situation where everything is really fuzzy, you're not quite sure how the code is supposed to look, and if you are running experiments on some kind of cloud resource, you can even have different metrics and logs come back to the pull request associated with the experiment that you run on the cloud. So using Git and GitHub are some really, really powerful tools to include in your MLOps pipeline. Even when it's time to deploy changes, you might have a GitHub action that executes just so you can get your configs right, or you can set some of your environment variables. It just depends on how you and your team decide to set up your entire pipeline, but with Git and GitHub, you at least have a way to make sure that you can automate kind of the things around the code portion of your experiments. So let's take a quick look at an example of setting up a Git project. So I'm going to switch over to VS Code, And this is our same project that we've been working on the whole time. So, of course, this one will already have Git set up, but when you're starting a new project or you want to add Git tracking to an existing project, the command that you need to run is called git init, and this creates a new Git repository in your project. So if you were able to see, take a look in Finder just so you can see this hidden file. Okay, so maybe I don't remember the quick key to show hidden files, but in your project, when you look for any of the hidden directories in your repo, you should see a new directory called .git. And this is just where Git keeps track of the hashes of all of the code changes that you've made. So after you have your Git repo initialized, which again is git init, then you'll probably need to set up some remote location to push these code changes to. So that is where GitHub comes in. And typically you'll run some commands like git add remote origin mlops demo. Something like that is what you'll run in your repo to connect the repo that you have locally to the repo that you have in GitHub. So you might need to handle some credential things here to make sure that you and your team have access to this repo. If there's any, sensitive information or there's just anything that needs to be private, you'll want to make sure that you have the right credentials set up for this repo. So once you've connected your local Git project to your GitHub remote repo, then you can just start to freely run experiments, change your code, and push those changes as you make them. So we'll take a look at some of the pull requests that we have here. And let's look at this one. So this is just a pull request where it looks like some of the hyperparameters were changed. The way that we actually get this pull request from our local machine to the GitHub repository that you're seeing in the browser is by running a few different commands. So first you'll want to check the status and see what all files and directories have been changed, because you might not want to push all of the changes that you made if you're still experimenting with things. So in this case, let's just say I want to push this new requirements txt file, and I'll leave the others for now since we'll be making changes to those. And now you'll see that Git has noticed there's been a modification to this requirements.txt file, and there have been some changes to these other files and directories. The difference here is that this requirements.txt change has been staged, and that means it's ready for Git to track this change. So what we would do after we've added this, we would commit this change with a message like updated packages. And now that code change is a part of our Git history, and if I run git push, you'll notice that it contacts the remote repository on GitHub. And if I come back over here, you'll see that there was a code change just now, and we'll take a look at the commit history, and you can see where we just pushed this updated packages requirement.txt change. So that's a quick run through of how Git and GitHub works and how it will help you to start automating some parts of your MLOps pipeline.